Hello everyone, my name is Beck and I'm a software engineer in Unity Technologies. Today I'm going to talk about the Unity Accelerator and how you can accelerate importing and updating your projects using it. Here is the outline of my presentation for today. First, I'll talk about asset importing briefly, and then cover the reasons why we are talking about asset importing at all. Then, I will tell you about caching and how caching is used in Unity projects. After that, we will talk about the Unity Accelerator. The next will be a comparison of the Unity Accelerator with the cache server. And here I would like to note that whenever I say cache server, the old cache server or the legacy cache server, I will be talking about the cache server which Unity had before the accelerator. So please don't be confused when hearing these terms. I will use them interchangeably. In the second part of the presentation, I will briefly introduce M2 project and tell you about how we were able to reduce asset importing time from 2.5 hours down to 30 minutes by using the accelerator. All right. Before jumping into the Unity Accelerator and caching, let's review briefly what asset importing is and why it is required. As we know, in a game or a real-time application, the asset data is not used by the hardware directly. It needs to be in such a format that the hardware such as the CPU or GPU could use it immediately. But most file formats are optimized to save storage space. They use compression and various other optimizations that prevent them to be used directly without conversion. So, Unity needs to convert the data from the asset source file into a format that it can use in a game or real-time application during runtime. For example, when Unity imports a PNG image file as a texture, it doesn't use the original PNG formatted data at runtime. Instead, it creates a new representation of the image in a different format, which is stored in the project's library folder. The texture class in the Unity engine uses this imported version, and Unity uploads it to the GPU for real-time display during runtime. The actual file remains unmodified, and the processed and converted versions of the data are stored in the asset cache inside the project's library folder. This whole process is called asset importing. So, you might ask, what's the big deal with asset importing and why are we talking about it today? Well, asset importing can become a time-consuming process. As the number of your assets grow, opening the project after the assets are updated or platform switch can take a while. For example, you come back to your desk in the morning, see that some of your colleagues have changed some of the assets, and then you get those assets from the version control system. After that, you open your project and wait for, let's say, an hour until all changed assets are re-imported, updated, and you can work with the project again. Especially, this can be painful in platform switch, where almost all assets need to be converted to their appropriate platform version. Then, how can we solve this problem? The solution is caching. As we said above, after an asset is imported, Unity stores the imported version of that asset in the asset cache. The asset cache is located in the library folder of the project on the local machine. but that library folder is never checked into the VCS because Unity can always recreate an imported version of an asset from the source asset file and its dependencies. So we already have the converted versions of the assets in the project's library folder. Then why not cache them? And we can use a couple of methods to do so. The first is the classic method, where you make several copies of the library folder of your project for each target platform like shown in the picture. When needed, you just replace the library folder with a pre-copied version of the target platform. For example, you're making a game for Android and iOS. You have tons of assets, importing of which takes a long time. And in order to quickly switch between Android and iOS platforms, you back up the library folder for each platform when you open the project for that platform. And when you want to switch the platform, let's say from Android to iOS, you close the project, go to the project folder, and replace the library folder with the library folder with iOS assets. Then you reopen the project, and that's it. You changed the platform instantly. Well, almost instantly. And to switch back to Android platform, you have to just repeat the same steps with the appropriate library folders. Yeah, it might work for platform switch well, but breaks when some assets are changed actually. Changed assets means you have to re-import all those assets again and make other copies of the library folder for each platforms you need. Another issue with this approach is the size of each library folder. If your library folder is, let's say, 10 gigabytes, you may end up using extra 20-30 gigabytes for extra 2-3 platforms. But nowadays, the storage space is relatively cheap and it might not be a big issue. And the second and a better way of caching is using the accelerator. The Unity Accelerator is a local network proxy and a cache service. Its goal is to help to reduce the iteration time. The accelerator coordinates asset sharing among the team members working on the same local network so that they don't need to re-import portions of the project. When installed on the local network, the Unity editor communicates with the accelerator to store and retrieve assets that other team members need changed or built. The accelerator keeps copies of imported versions of the assets to avoid wasting time re-importing them. This means that only one person needs to perform the actual re-import, and the results will automatically be cached to the Unity Accelerator. The next time a team member goes to import the same version of the asset, the cache will be first checked before starting the import process on the local machine. As we can see in this picture, when there is a change in the assets, every member gets those changed assets first and then starts to re-import them individually on their machines. The problem here is each of them will execute the same re-importing operation for the same assets, thus wasting time. But this changes when we use the Unity Accelerator for caching imported assets. As you can see here, when there is a change in the assets, everybody will get those changed assets into their local machines. But this time, only the first person to get a particular changed asset has to re-import it. When he does it, the imported version of the asset will automatically be cached to the accelerator. Others will just download the imported version of the assets from the accelerator when they need it. Now, let's see the workflow of these two cases in detail. First, let's see how assets are imported when there is no accelerator. There are 3 users in our example, A, B, and C, and they have a version control system in their environment. User A changes some assets. Then he imports changed assets locally. The reimport time takes 20 minutes in total. After he is done working with the assets, he will push them to the version control system. Later, user B pulls changed assets into his local machine and reimports them. This time also, the reimport time takes 20 minutes. Then user C pulls changed assets too, and he also starts reimporting them. Again, it takes 20 minutes to reimport all of the changed assets. The conclusion here is every user is spending some time to reimport changed assets. This time, let's see how the workflow changes when we introduce the accelerator to the system. We have the same setup with 3 users and a version control system, except that now we have an accelerator added to the environment. User A changes some assets, then he reimports changed assets locally. This time, the imported versions of the assets are automatically cached to the accelerator. Like in previous case, the total time spent for reimporting the assets is 20 minutes. Then, user A pushes changed assets to the version control system. Now, user B gets the changed assets locally and starts to reimport them. But this time, not like in previous example, changed assets are not reimported. Instead, Asset Database version 2 downloads the imported versions of those assets from the accelerator. The whole reimport process takes only 2 minutes this time. The same situation happens with user C. He gets the changed assets and starts reimporting them. When Asset Database version 2 detects that the imported version of the assets cache exists in the accelerator and just downloads them. And again, the whole reimport process takes only 2 minutes instead of 20 minutes originally. The conclusion is using the accelerator for caching helps to reduce project update time significantly. Now, let me quickly demonstrate to you how you can use the accelerator to speed up project import and platform switch in the example of M2 project. I will speak about the details of M2 project a bit later. Okay. Here we have the project folder where the library folder is missing. This means that the project has never been opened on this machine. Well, of course, I've opened it before, but for the sake of the demonstration, let's assume that it has never been opened. Also, I've cleared all Unity cache folders so that it would not affect the time calculations that we're going to make. Okay, let's quickly check the size of the assets first. Here we have assets with 4.76 gigabytes. Now let me start the stopwatch and open the project. As it will take a while, I will fast forward the video to the point where the importing of the project is finished. Okay, let's stop the stopwatch, and it took 3 minutes and 40 seconds to open the project. If we check the size of the library folder, it's a little bit more than 5 gigabytes. Now, let's go ahead and switch the platform to Android. Let me first reset my stopwatch, start, and switch platform. Alright, it took just 35 seconds to switch to Android platform. If we go and check the library size this time, it's a little bit more than 6 gigabytes, where it was a little bit more than 5 gigabytes in Windows case. And let's check how long it takes to switch back to Windows platform. Start and switch platform. All right, 15 seconds. It just took 15 seconds to switch from Android to Windows. So as you can see here, without doing any extra work, we were able to quickly switch between platforms. No copying, no backup was required, just using the Unity Accelerator. Now, let's talk about the Unity Accelerator versus the cache server. As you most probably know, Unity has a cache server which has been around for a while already. It works well, but it lacks some features that the Accelerator supports. If you go to the Unity forums, there are many questions like, you already have a cache server, why do you need another one? Or what's the difference between the cache server and the Accelerator? Well, here you can see the main differences between the Accelerator and the original cache server in one page. The most important difference is that the original cache server only supports Asset Pipeline version 1, but the Accelerator adds caching support for both Asset Pipeline version 1 and version 2. I should mention it here that the Asset Pipeline version 1 support in the Accelerator is achieved by installing the original cache server as a part of the Accelerator installation. The next great thing about the Accelerator is that it supports caching custom assets via scripted importers. I'll talk about this feature in detail in later slides. The original cache server didn't support this feature out of the box. The next feature is automatic disk storage management. This means that the Accelerator will periodically clean up unneeded assets data. With the original cache server, however, you often had to use additional tooling to manage disk space. Another great feature of the Accelerator is matrix provision. The Accelerator exposes metrics that provide you with useful information such as bytes transferred, editors connected, and more. The next comes mirroring multiple instances. The Accelerator is able to sync its cache data with other accelerators in order to provide the fastest import times. When teams are spread geographically in different locations, This feature makes sure to keep the download time of the imported assets in minimum. Also, the accelerator can be integrated with Unity Collaborate service. I'm not going to talk about this feature in detail today. You can refer to our website to get more information about the Unity Collaborate service. Cache Server supports the versions of Unity up to 2019.2, whereas the Accelerator supports the versions starting from 2019.3. And regarding the development state, the Accelerator is now being actively developed. This list of features are not all of the features that the Accelerator will have in the future. The Accelerator team is currently working on bringing some more features with each major update. And the original cache server is currently in maintenance mode. There will be no new features added, but you can always use it with your projects that use Asset Pipeline version 1. Okay, so when comparing the Accelerator with the old cache server, I mentioned about the feature of the Accelerator to provide metrics via its dashboard. Before jumping into the next section, let me show you the dashboard and metrics the Accelerator provides. The easiest way to access to the dashboard is via an internet browser. The dashboard consists of metrics, configuration, and logs sections. The metrics page shows information such as the current installed version of the Accelerator, how much disk it is using, and CPU utilization. Also, in metrics page, you can check how much data has been written into the cache and how much has been read from it since the installation of the Accelerator. In this particular page, clients have written 124 gigabytes of data into the cache, whereas they read almost 3 terabytes from it. You can configure various parameters of the Accelerator in configuration page. For instance, you can check the port the Accelerator is using or check where it is installed, set the maintenance schedule and data policy. The logs section provides detailed log of the Accelerator's operation. Now let's talk about M2 and the Accelerator. M2 is an open world project which demonstrates the power of Unity in creating vast open world projects for mobile platforms. It introduced new features such as HLOT, box slides, shadows, and clip map terrain. If you would like to get some more information about M2, please visit our YouTube channel. There are a couple of videos that explain M2 in detail and about what kind of new features it brings. So, why we needed to use the Accelerator with M2? M2 is a pretty big project, and the project update and import time would take a long time. The platform switch would take even a longer time. Moreover, after each commit, a set of tasks need to be run for every target platform, for every target Unity version on macOS and Windows. We needed a fast iteration time and needed to know if the commit would break anything. The Accelerator helped us to solve all issues listed above. Here are some statistics about M2. There are more than 3,000 assets in the project, as you can see in the picture on the right, and almost half of them are HLOT assets. HLOT assets are custom assets that use scripted importers in order to be converted into an internal Unity format. I will talk about scripted importers briefly in the next slides. Importing HLOD assets is not fast, and taking into account the fact that there are around 1,500 of them, it makes the project import time really slow. By using the accelerator, we were able to reduce the import time and platform switch time significantly, as you remember from the demonstration I did just before. For instance, compiling the project on Windows was reduced from 35 minutes to 17 minutes on average. These screenshots are taken from our CI system. On the left, we can see 5 jobs that finished in 35 minutes on average without using the accelerator. And on the right, it took 17 minutes to finish the same jobs on average when using the accelerator. This page compares the time taken for building the M2 Android player with and without using the accelerator. On the left is the build time without the accelerator, which is 2 hours and 23 minutes on average. On the right is the build time with the accelerator, which is 35 minutes on average. As you can see, we were able to reduce the import and build time of M2 project significantly by using the accelerator. If you visit our Unity blog, there is an excellent post named Speed Up Your Team with the Unity Accelerator, written by my fellow colleagues in Unity. You can find the link to the post at the bottom of the slide. They have conducted an extensive testing of the accelerator and the Collaborate service. According to the results they have received, with around 12,000 files and 100 megabytes in size, updating the test project would take on average around 6 minutes, whereas with the accelerator, it would take only around 30 seconds to update it. The accelerator helped to reduce the update time up to 90% on average. Now, let's talk about scripted importers briefly. Scripted importers are a part of the Unity scripting API. They are used to write custom asset importers in C# for file formats that are not natively supported by Unity. For example, if you have your own format, let's say .abc, you have to write a scripted importer to make your .abc format understandable by Unity. Otherwise, you cannot use the asset in your project. We used scripted importers in M2 to import custom HLOD assets. Before the accelerator, we used the legacy cache server, and we had to write our own cache server client to cache HLOD assets, which was not an easy job to do, and it was error prone. Now, with the accelerator, we are able to cache any custom assets by adding just a single parameter to the importer attribute. For example, before the accelerator, with the asset pipeline version 1 and the legacy cache server, we had to write the import logic first, and then we had to write custom caching logic. But with the accelerator and asset pipeline version 2, all we have to do is adding this parameter to the scripted importer attribute. And that's all. You don't have to do anything extra. You just have to concentrate in your import logic. Asset pipeline v2 and the accelerator will take care of the rest. As the last item of today's presentation, I would like to show you how we set up the CI system for M2 project and how we use the accelerator within this system. This is not the exact setup we have, but it is simplified for the sake of better understanding. On the left side, we have a team consisting of 3 users, each of which focus on working with specific parts of the project for a specific platform. Let's call them Windows, Android, and iOS player users. And let's assume they're in the local office in Korea. The office has a version control system and a Unity Accelerator server. On the right side, we have a build farm, which is located remotely, let's say in the UK. And there we have a continuous integration server and an accelerator server. Now, let me show you how the system helps to accelerate asset importing. Let's imagine the Windows player user changes some assets. After he is done with re-importing them, the imported versions of those assets are pushed to the local accelerator server, like this. Then he pushes his changes to the version control system. Now the version control system sends a callback to the continuous integration server, notifying it about new changes, like this. The continuous integration server will start a number of jobs to run tests and to build standalone players targeted for various platforms. In our example, we are building players for macOS, iOS, Android, and Windows. These jobs will each build their corresponding players, and while doing so, they push the imported versions of assets to the accelerator. When the jobs are finished, the accelerator will have imported versions of assets for Windows, Android, iOS, and macOS platforms. So you can ask why we're building so many platforms at once at this stage. Because somebody else might need them in the future, as we can see a little bit later. As I mentioned before, the accelerator has a mirroring feature. After some assets are cached, the mirroring feature of the accelerator will kick in. And the cached contents of two accelerators will synchronize. Now, the accelerator in Korean office will also have the imported versions of assets for Android, iOS, and macOS. Now the Android player user pulls the changes. As we already have the imported versions of assets for the specific revision that the user is pulling, instead of re-importing all changed assets and spending, let's say, 20 minutes, he will just download the imported versions of the assets for Android platform in 2 minutes, like this. If we haven't built the Android player via a CI job in advance and cached the imported assets, the Android player user would have done this by all himself. And the same situation happens with the iOS player user. He pulls the changes and just downloads the imported versions of the assets for iOS platform. And here it is worth to mention that the accelerator will keep the imported versions of each revision of assets as long as there is enough disk space. When there is a new revision, the accelerator will keep all of the revisions in place. For example, these revisions of imported assets will be stored accordingly. You can check out an earlier revision of your assets safely without worrying that you will have to re-import them again. You will just download the imported versions of your assets for that specific revision. When there is not enough disk space, the accelerator's data eviction mechanism will kick in and remove all the revisions of imported assets. Okay. Thank you everyone for attending this presentation. I hope that things you've learned today may come handy to you in the future. If you have some questions, feel free to leave some comments below and I will try to reply them as I can. Thanks again. Bye.